I'm super happy that we are restarting this HCI Seminar series. And our first speaker today is Rubaiat Habib, who's a senior research scientist at Autodesk Research. And the reason why I was so excited to have Rubaiat here today is because he combines his kind of private passion for drawings and paintings with his research. And I think that's always like the best way how you can get like really successful, deep, meaningful papers published. So he received, so ACM Chi and ACM Viz are our kind of most premier venues in HCI, and he has received 2 Best Paper honorable mentions, and he has also received a couple of Best Talk awards. So with that, I want to give the word to Rubaiat.
Thank you very much, Tiffany, for the introduction, and thank you very much for showing up. It's my greatest pleasure to be here to share and exchange ideas with you and share our work with you. So is there anyone in the audience who loves to draw and paint? Anyone? Quite a lot. So we use pictures in our presentations, papers to augment our thoughts, to represent our thoughts, to communicate with others beyond verbal language and pictures. But wouldn't it be great if we could bring life to those drawings, make those dynamic and interactive? So this talk is all about making those diagrams and pictures that we use in our day-to-day activities interactive, give them behavior and give them life, and empower a wide range of audience with the power of dynamic graphics to enhance new ways of communication, thinking, and expression. So before getting into the talk, I'd like to talk a little bit about my background, what really got me interested in this line of work. I grew up in Bangladesh, and from my childhood, I liked to draw and paint, and I'm a visual thinker. Without a pen and paper, I cannot even think. Now, I got into computer science department in Bangladesh, but I still continued drawing, painting, drawing cartoons for magazines, published comic books. As a matter of fact, I've also written my PhD thesis as a comic book, and thanks to my and I'm really glad that I got away with it from the university. But thanks to my supervisor Shendong Zhao, who encouraged on me.
Is that it on the left?
Yeah, that's it. But it's 40-page comic book actually. Yeah. So the basic idea is that we want to share our ideas, our design ideas beyond researchers and scientific communities, right? So the goal was to communicate these scientific ideas with storytelling and art so that it could reach out to designers and engineers. Anyway, as a creator, these drawings and characters were not just static pictures to me, right? In my mind, they're real characters. They're real, they're talking with each other. And in my mind, I communicate with these characters. But the living phenomena of these drawings and characters are not portrayed in this drawing. These drawings are dead as a doornail. So, but every day we experience dynamic graphics in the context of 3D animations, cartoons, and so on. But creating these kinds of expressive graphics is still challenging, right? You need to use very complicated tools and processes. In Mitch Resnick's words, you can read this media, but you cannot express using this media. How frustrating is that, right? So there's a great quote from Walt Disney. Animation can explain whatever the mind can conceive, which makes it the most versatile and explicit means of communication. But it's really unfortunate that most of us who are not animators, we cannot leverage the communicative aspects of animation in our day-to-day activities, in papers, presentations, or any other form for brainstorming. So in order to make dynamic graphics accessible, we have to make animation accessible. That's the first thing to do. So in this line of work, our first project is Project Draco, which was published as a Chi paper several years ago. But now, yeah. So this was first published as a Chi paper, but now it's available as an iPad app in iTunes. So I will just do the demo using Sketchbook Motion. It's named as Sketchbook Motion. So the goal of the Draco is that to make animation as easy as sketching and bring life to drawing with kinetic textures, without the complications of timeline, keyframing, or other time-based animation tools. So you see, just like any other drawing tools, there is all these layers. And let's say that I want to add some animation effects into it. So to do that, I will first add some bubbles to the diver. So sketch some bubbles. And then I want to create a texture out of these bubbles. So I create a texture. And this creates an animated texture from the example strokes. And then let's say that I want to specify the direction of the bubbles. So what I have done is that I have created a texture and specified a global fill for the bubbles. But sometimes we want to add some jitterings just to bring some randomness and into the bubble. So we could also add motion on a granular scale. So I can record a jittering motion to the individual bubbles. And you can see the bubbles are now jittering. That being replicated to all the bubbles. So you can make it more subtle. And then we also want to change some parameters. We want to control the behaviors as the bubbles are moving. So let's say that I want the bubbles, when they come out, they should have a higher speed and then they should slow down. So this is the value of the attributes as they're moving along the path. So again, there is no time, it's just path. Time is represented spatially. Maybe like this. And then you can also control the scale so that as they move, they will get bigger, or vice versa, or maybe something like this. You see, they get smaller. And then similarly, we can control the opacity. As they move, eventually they will disappear. So opacity will become 0. So now we have an animated texture. So now let's control the fish. In this case, I want to create a school of fish. So again, I create a texture. Specify the direction of them. Control the emission, high speed. And then I will again add motion on a more granular scale, add some jittering. Too much, maybe settle calm down. And then maybe control the speed just to bring the variation a little bit, just to vary it a little bit. Change the scale a little bit. That's it. So now let's add a seaweed. So in this case, I'll just draw the seaweed. So I sketch some seaweed. And then create a texture. So this creates a seaweed texture. Control the spacing. Okay. Now animate the whole texture. See, what I'm doing is that just specifying something like keyframes so that it oscillates between the two positions. Now, what we have done is that we have animated the whole texture, and just like the texture before, we want to add some randomness. So what we will do is that we will record a motion on a granular scale. So you see now that rotation is being applied to all the strokes. So we have created a dynamic drawings. So you see there are two basic elements here. First of all, it's completely by example. There is no physics into it. Everything you create is the examples and samples provided from you. So which makes it a very expressive framework. And at the same time, the fact that you can give motion control motions in global and granular scale makes it a very really expressive medium. So I made some layers invisible before. So when I make the layers visible, this is how the resulting drawings looks like. This is the final drawing. So you see, it feels like you're like drawing the animations, right? It doesn't feel like an animation tool, but it feels like a sketching tool. And here are some other ones. And here are some animations from external users. So this is done by Ko Mariyama, one of the VFX animators. This is by one of the cartoonists, Rina Piccolo. And this is titled Patience, the title of the drawing. This is by David Clark. All right. So typically how it works is that we develop the research prototype, and then we work with the research team. The research transfer team takes the prototype code, application code, and makes it close to a product. They don't deploy it, but they make it a deployable version of that. And then the research transfer takes over. But what's interesting about dynamic drawings is that it's not just about the tools and interface. It's a new medium. So it's absolutely critical to create a community of people who are enthusiastic about the medium. So we engage with a lot of artists and designers in the early phases of development, and they surprise us with their creativity by creating amazing content. And this made a huge difference at the end. So I will show some other drawings that was created by our beta users and testers. But what's interesting to see is the range of application domains. It was not just artists and animators anymore. You can see some architectural renderings in the left and some civil engineering drawings in the right. And suddenly all these people who didn't know how to use animation tools, they could, by dynamic drawing, they could express their ideas more effectively. Some educational tools. And we also got a lot of feedback how kids love it. But we also got some negative feedbacks as well. I mean, someone complained about that he can't sleep because he can animate too easily in bed. So this is Ko Mariam, who is the VFX animator. Now, last year, December, one fine morning, I woke up and I was just browsing Twitter and see what Donald Trump said about others and not. And then all of a sudden, I saw that Apple announced Sketchbook Motion as the best iPad app of the year, which put it on the top of 1 million other apps in the App Store. So this was a great recognition for us, especially for all the amazing collaboration between all the divisions and groups to bringing out a research idea into this. But I believe that it's just the beginning of a very exciting future, an exciting journey. So I'll talk more about this later. We also wrote a research article about how to use animated research articles with animated figures. In fact, to the best of our knowledge, Draco is the first SEM paper in SEM Digital Library with embedded animated figures. Yeah, I strongly encourage you to look at the SEM interaction articles and try it out. There are also some guidelines how to use these animated figures in papers. Okay, so Draco looked at how can we bring life to drawings with animated textures. But now we are looking at how can we give behaviors to those pictures so that someone can interact with it to see how things work, how things are connected with each other. So this is called Kitty, a sketch-based, again, another sketch-based prototype that helps you to create interactive drawings. And this is an example of an interactive drawing. So you see I'm interacting with the drawing as I swipe. Changes the scene, right? The velocity of the bin is increasing. But at the same time, you can see other things happening in the scene. The windmill is rotating faster, there is more water emission. Now, if I swipe from top to bottom, it starts raining. If I swipe even more, it rains even more, and at some point you can see thunderstorms. So dynamic drawings, as a viewer, it helps us to understand how things work, what are the cause and effects. And Brett Victor believes that dynamic picture will someday become the primary medium for visual art and exploration. And personally, I believe that that is imminent. We will have it in near future. What happens with dynamic pictures is that they are driven by data and parameters. As you interact with the picture, some parameter changes. The parameters can be rotation, it can be opacity, it can be anything else. And sometimes the parameters are connected. So this is actually the tool itself. I'm presenting with the tool. Now we started thinking, how should these dynamic pictures as a medium look like? You know, pictures is a kind of medium, just like written language, and we should be able to represent a wide range of thoughts, expressions, and other things with this medium. So what will make it a versatile medium so that we can accommodate a wide range of expressions? So there's a great book by Dan Rom called The Back of the Napkin. And in this book, Dan Rom explains how we see things and how we represent our thoughts. And this is the things that we all see. So we see who and what objects, we see how much quantitative information, we see where, we see when, which is temporal information, time. We see how things are connected to each other, and then we have a high level understanding of things. And this is how we represent all those informations. We use portraits, objects to represent objects. We use charts to represent quantitative information, maps for spatial information, timeline for temporal information, flowcharts for cause and effects. So this gives us a really nice framework about how to think of a medium. A medium should be able to represent all these different types of concepts and ideas. Okay. Now, here is an animated picture. There is no interactivity into it. So we will make this drawing interactive with Kitty. So in this case, as you can see, the cat is hungry and he wants to have the egg, right? But the cook is thinking otherwise. So let's say that in the interaction mode, I select the egg, and the viewers will be able to move the egg along this trajectory. So now I, as a viewer, in the interaction mode, I can interact with the egg. I can move it along this trajectory. No, but there are cause and effects as well, right? Sometimes when the egg is here, I want to have a splash of the soup, right? I don't want the splash of the soup otherwise. So we switch to the graph mode, and you can see all the abstract representation of these nodes. So in this case, let's say that I create a relationship from the egg to the splash. And you can see there is all these other types of parameters. I mean, each of the node has a parameter, and we choose the parameter in such a way so that this parameter represents spatial information like path, visual attributes like opacity, colors, and also temporal attributes like motion and so on. So in this case, the emission of the splash is dependent on the translation, right? So we create a relation. So the relation is such that the emission should be 0 up until this point, and then there will be a splash, and then it will become 0 again. Okay, so let's see. So there's a splash here, and then it becomes 0. Only when the egg is here, you can see the splash. So you have created a very simple relation. But it will also make the cat disappointed, right? So let's author that one. So we create a relationship from the egg to the cat's eye, so that it's follow the egg. And then create a relation to the cat's mouth so that the scale of the cat's mouth becomes smaller. So now look at the cat's reaction. Poor kitty. Poor kitty. So this is also an animated diagram, but it's not interactive. But I want to make it interactive so that as I move this along the trajectory, I can see how the weather condition of that particular day. So I have an Excel file of the weather prediction, and I want to see the weather of that day. So you see, this is clearly my wife and myself, and I don't like winter, and she clearly likes it. Now, I load the Excel file from here, and you can see all the weather attributes here, right? Snow, wind, temperature. Now I create a relationship from the calendar to the snow, and the emission should be dependent upon the calendar, and then the relationship derived from the snow data. So you see, at the end of the week, there is more snow. It's derived from the data. And then I create another relationship from this to the wind, and derive the functional relationship from the wind data. End of the week, it also gets windy. And then if there is more wind, there will be more just jittering into the snow. So now we have a data-driven infographics.
Can I ask you, how did you indicate that it was the wind in the spreadsheet that was associated with the wind element? Or
There was a wind column here.
And the element in the animation was labeled with a name that matched that previously?
No, there was no labeling in the animation. So the level is done with the relationship. If I go to this graph here, whenever I create the relationship, I choose that data attribute, and that will create
okay,
this.
sorry. Yeah, I thought you were creating it then.
Yeah. So now, in the beginning of the week, it's pretty nice actually. There is no snow. It's not that windy. In the middle of the week, it's snowy, but it's still not that windy. But in the weekend, when you are planning to go out and hang out with your friends, snowy and windy, it's really bad. So you see, we have created a data-driven infographics with Kitty. And then how about temporal information? So this is a comic scene showing how a scene changes over time. With Kitty, we can consolidate it into a single dynamic illustration. So this is an example of temporal events. How can we represent temporal events? And this is the relationship graph. And finally, you can see how it could be powerful for educational tools. This one shows how a mechanical bell operates. When the button is pressed, electricity starts to flow. This charges the magnet, eventually attract the iron armature, causing the bell to ring. So this is an example of like a state diagram. What are the different states? And all these things took like 4 to 5 minutes to create completely from scratch. And this is the relationship diagram from this one. So you can see as a medium, the expressiveness of the tool. As an educator, you can show how a certain system works. As an infographic designer, you can create data-driven infographics. As a researcher or engineer, you can show how your hardware and software system works. So that's what we are aiming for, creating an expressive system. And this paper was published in WIST, and these are my co-authors, Toby, Fanny, George, and myself. Okay, so but animation is not just moving pixel around the screen, right? Animation is way more. It's about the art of dynamics, art of time and space. And look at this drawing, right? It's so fantastic. It touches our heart and emotion. And then we started thinking, how can we bring that kind of dynamics into our animations, into our drawings? Now, from a user point of view, the challenge is that number one, how can we represent those dynamics so that it's easier to understand, comprehend? Second, how can users effectively apply those dynamics? Now, often the problem is that these kinds of classical dynamics or the cartoon dynamics, they're very abstract. It's hard to characterize them. One great example of the Disney principles of animation. The animators in Disney developed these 12 principles of animation to create stylized, exaggerated dynamics. Together, these principles guide the motion design, visual design, timing, and other attributes of animation like squash and stretch, arcs, and so on. Now let's think how an animator thinks, how a master animator thinks about an animation. How do we create this animation in his head? Forget about the interface for now. He would first add follow through, and then add staging for the motion lines, slow in, slow out for the timing, and then squash and stretch. So this points to an important attribute to this dynamics, that the composable nature. Complex dynamics arise by composing simple, understandable principles. It also points to another important attribute of this animation is that animation as a medium has its own language. When two animators talk with each other, they don't say that you should increase the parameter this or that. They give feedback like this. I think you need a bit more anticipation. I think you need to increase the staging. Or I think you need a bit more squash and stretch. So they have their own language of specifying their ideas and goals. So Motion Amplifier is also a research prototype which looks at how can we bring this exaggerated cartoon dynamics into hand-drawn sketches. So this is the user interface for motion amplifiers. So let's say that this is a simple character. Let's say it's me. I'm super happy to be here, sharing ideas with you, giving talks. And then I create an object from all these strokes. As I create the objects, you can see all the animation principles of the top of them. We call them motion amplifiers. Now let's say I record a motion, simple motion, from left to right. Now it just starts moving from left to right, but it looks dull, right? It's not looking interesting. Okay, now let's say I apply slow in, slow out. To apply, I simply tap the amplifier and it immediately exhibits that behavior. Let's say I apply staging. This will create the motion line. Let's say if I apply squash and stretch, so you can clearly see some stretch behavior. For each of the amplifiers, you can control its strength. So this is a really strong squash and stretch. Let's say that I want to apply drag. Now it's exhibiting drag behavior. So you can also specify where to exhibit the drag behavior. Okay. So this is an animation which exhibits these 4 principles. Let's say that I want to take away the drag and see how it looks like. Take away the staging, take away the squash and stretch, bring back the drag, and bring back the staging. So you see, it exposes the principles in a way where first, it's easy to understand what each of them adds to the animation, and secondly, it inspires you to do experiment with all these different ideas, right? You are learning by experimenting with them. So here is another one. Right, sharp animation. So in this case, select the objects, specify arc, record a motion there, apply slow in, slow out, staging, then apply squash and stretch. Probably I want a bit more squash. Yes, so I'm talking to the computer as if I'm talking to my colleague, so leveraging the human language. And how it would look like if I had some anticipation. So I added some anticipation and you see the shark is going back before moving forward. But you can also manipulate the anticipation pose. You can say the pose should be like this, or like this maybe like this. So yes, we have created a stylized animation using the principles of animation. All right, so this is a clock animation with Sketchbook Motion. If we apply squash and stretch and slow, this is how it looks like. If we add drag and staging, this is how it looks like. You can clearly see what each effect adds to the animation. This is vice versa, where it has 4 amplifiers. If we take away the drag, if we take away the squash and stretch. So I think the most powerful aspect of this interface, or in particular this type of idea, is that from a pedagogical point of view, it creates the condition for invention, not providing ready-made language, right? This is what Seymour Papert said. The role of the teacher is to create the condition for invention, where animators can learn about all these principles by experimenting with them. And this is evident from our user studies, because these people have never done animation before. This is the first time they used the tool, and in a few minutes they were able to create this animation and apply all these principles effectively. So they never knew about these principles before. This is Mad Rat, inspired by 2 films, Mad Max and Ratatouille. Okay. So, but the interesting aspect of motion amplifier is that how do we draw the boundary between style and principle? We often talk about style, not only in the context of animation, but in the context of design and pictures and paintings. To me, the principle of animation is just a particular type of style, nurtured by the Disney animators. But there are some other interesting questions. How these principles show that you can break down styles into these understandable amplifiers. Style is composable of simple understandable blocks. Probably we can represent other styles in these forms. And in that case, probably we can mix between different styles. And even more, probably artists can define their own style by defining their own motion amplifiers. So I think these are really interesting and interesting questions worth researching and worth considering. Okay, so we have seen cartoon animation, textures, interactive, but as an artist, what really intrigues me is the special effects animation. Look at these drawings. if you go in animation studio, you will see that they have a separate department for VFX because this is a very stylized, very specialist type of skill. Now, what makes these types of animation very complicated is that they're changing over time. They are passive, they are driven by external energy, but those energies are changing over time. So all the effects you see are secondary effects. So this is why it is really challenging to control them, stylize them. This is a classic problem in computer graphics, how to stylize and control physics-based animations like this, smoke, explosion, fire. But hand-drawn animator had a very different approach when they designed hand-drawn special effects animation. Not using any tools, just like when they're conceptually designing these tools with pen and paper. So they draw these coarse animation strokes to define the energy. And as Joseph Gillen says that we do not animate things, we animate energy. So this is very different from traditional special effects animation. Firstly, because it helps you to focus on the core thing, which is the energy. And secondly, it gives you a lot of artistic control, right? You can put over the strokes wherever you want. And that artistic control is really important because sometimes you might have a smoke effect that have an evil spirit, right? It's not just physics-based smoke, but have a certain characteristic, smoke that is very happy, something like that. So we started to look at, okay, how can we apply this idea into computer-aided hand-drawn special effects animation? So Energy Brush looks at this problem. In this case, the idea is that you take a drawing like the one in the left, probably in different layers, and then add the strokes, which is the energy brushes, and then this will create the animation like the one on the right. And here's the video.
Secondary animation effects for elemental dynamics, interactive energy brushes for stylized elemental dynamics. An energy brush creates a stable, repetitive velocity field pattern of moving flow particles along the gesture. A flow particle creates a local velocity field that influences the neighboring shapes. Different types of flow particles create different types of velocity fields for detailed dynamic effects. We now sketch 3 strokes and specify their anchors. These are the resulting dynamics. We can interactively edit the brushes and fine-tune the effects, and view the changes in real time. Interactive interface, energy dynamics arise through interactions among simpler energy patterns that themselves do not exhibit such properties.
So again, the main idea is that, physics-based simulations are really complex, they're hard to control, they're hard to understand how they will work. Break down into simple energy patterns, right? Each of those brushes, you know how they work, what type of energy pattern do they create. And you can create very complex dynamics just iteratively adding one more brush. And so you can create something really complicated by interactively and iteratively adding those brushes. So this is another example where you create a smoke effect just using 2 brushes. So the first brush creates this energy effect, and the second brush, when you add 1 more brushes, it starts to add this randomness and chaotic behaviors of the drawings. So you can create from very realistic to very stylized effects. That gives you that control. And you can also potentially take any static photograph, crop parts of it, and animate them. So you can actually basically bring life to any other photographs. Some other drawings. The key idea of energy brush and motion amplifiers is breaking down complex problems into what Seymour Papert says as mind-sized bites. A mind-sized bite is a problem that is easier and for us as a human mind to understand and comprehend. So in the context of creativity support tools, we often interact with very complex algorithms in the form of machine learning, simulation algorithms, or other types of algorithms, photography filters. But sometimes as a creators, we don't know. We feel like we are working with a black box and we don't know how it works. But as a creator, we want to develop a deep understanding how things work, how things work, and how can I develop mastery into it. So breaking down complex problems into mind-sized bites might have powerful influence on how creators learn and apply those skills. So I have presented four of our projects in the context of dynamic drawings and illustrations, and I'd like to revisit some of the basic design principles. The basic idea is that represent time in space. Leverage users' intuitive sense of time and space to create animated effects. And then provide users absolute control. It's not like the magic animation and simulation algorithm comes and beautifies your things, but it provides users give the control over granular skills, multiple granular and global skills to create complicated effects. And then, as I said, break down complex problems. And also, we leverage existing practices, try to incorporate the existing languages and how animators think, and bring those ideas into the traditional digital animation workflow. And when we make all these things possible, animation doesn't become it's not just an art and storytelling medium, it becomes a powerful communication tool for our day-to-day communication. And I must acknowledge that there is a lot of great visionary researchers that work in this line of work. The work of Ivan Sutherland, Alan Kay, Mitch Resnick, Takeo, Brett Victor, Ken Perlin. I mean, all these people inspired significantly. Our work inspires our work. And you know, there is a lot of sketch-based interfaces in the research community, but they didn't catch up for some reason in the mainstream computing application. But I think the time is right. Now we have Microsoft Surface, Apple iPad, and so many other hardware platforms. We are there. And I believe that computer graphics will reach its full potential when we can make it a powerful medium for real-time communication across a wide range of application domains, not just animation and art and storytelling. Okay, I'd like to talk a little bit about my organization, Autodesk. At Autodesk, our vision is to help imagine, design, and create a better world. So our customers are mostly makers, innovators, and entrepreneurs of today's time. And we have a wide range of product portfolio. We have softwares for 3D design manufacturing like AutoCAD, Revit, 3ds Max, Inventor, and then tools like Maya for 3D modeling simulations, and then tools like Sketchbook for digital art and painting. And if you have ever driven a high-performance car or seen a skyscraper building, used a mobile phone, or blown away by visual effects of a movie, chances are you have seen what our customers are doing with our software. Our CEO once said that, you know, if it's not made by God, there's a chance that it's made by Autodesk software. So the role of Autodesk research is to help Autodesk and our customers to think in terms of strategy through scientific innovation and research. And I work in the user interface research group. It's led by George Fitzmaurice, who is also an MIT alumnus, but we do a wide range of work including software learning, machine learning, visualization, wearables. We had a wide interest. And we have a strong internship program if you're interested. And finally, I would also like to acknowledge all my co-authors and collaborators, without whom this work would never have been possible. And before taking off, I want to point out that, you know, all the interfaces you have seen, they capture a very small fraction of our input and output senses. They are just sketch-based interfaces. But when we talk with each other, we use hand gestures, body postures, expressions. Our input and output sense and channel is much wider, much broader. So it would be really interesting to see how computer graphics can leverage all our input and output senses beyond just pen-based computing. I'd like to show one example. Have you ever seen sand art or sand animation? Sand art is a way of telling stories to an audience by manipulating sand in real time in front of an audience. So it's a performance art technique. But the beauty of this art is that how an artist leverages all these different parts of his hand. It's like as if like the hand is a dynamic brush. They use the whole hand for a very coarse gestures, and then they use these fingertips for very fine and intricate details. Now, inspired by this, we developed a digital prototype named Sand Canvas. So you see, this is an interactive touch screen. But the beauty of this touch screen is that it has an increased bandwidth. As you can see, the artist is interacting not only the fingertips, but his whole gestures. He's making coarse gestures. Gives it additional levels of expressiveness. just by increasing the input bandwidth. So imagine what computer graphics can do when we can leverage the increased bandwidth of human senses for real-time communication. So I'd like to finish with one last very short video of Sun Canvas. Okay, thank you very much for your time.